So hello everyone, this is lecture 50 for the mathematical physics. In the last lecture we were discussing about the branch point singularity. So it was associated with the multivalued functions, and the singularity associated with it is called the branch point singularity. And I already told you what is this branch point. And if this is your branch point z equal to 0, then any contour enclosing this will give you different values depending on the order. If it is 2 order, then after 2 cycles you will get the same value but 2 different values. If it is cube root, then you will get 3 different values. And I already given you the example of this. Okay, so I already discussed this, how can we remove this singularity or the branch point singularity. Means you just need to take this branch point outside this contour, and that's how you can make this a single valued function. So I discussed two kind of functions. That is, first was this z squared, means power of z 1 by n, and log z. So we discussed these two, and for the log z it was of infinite order, and here it was depending on the n. If it is 2, then it is order of 2, and for n it is order of n, but here it was of infinite order. Then we discussed some results. That is, if this is kind of your function, then z equal to alpha will be singularity, branch point singularity, when this is a is fractional, and z equal to beta is singularity, branch point singularity, when this beta is fractional. Okay, and z equal to infinity is a branch point singularity if a plus b is a not an integer, so that should be a fraction. Only then we call this z equal to infinity as branch point. Now I given you this example. Now let's summarize this. For nth order, z equal to 0 is a branch point, or order n. So for this, only z equal to 0 is a branch point. If you are getting something z minus alpha, z plus beta, then that accordingly z means alpha and minus beta will give you the branch point. Okay, if it is log z, then z equal to 0 is a branch point and infinite order. So remember these things. So only these are required for the question paper according to the questions in the question asked in the papers. So now we will discuss about the branch line and the branch cut. So what are these lines? So let me just give you the idea that it is a line if you don't means it is that line if you don't breach or cut that line by your contour, then your contour will be single valued, means it is not a multi-valued, and you can solve the integral. So that is the branch line or branch cut. And how you made this? So let's see an example. If fz is given z square minus 1 raised to the power 1 upon 2, so it is a multi-valued function. So z equal to plus minus 1 is a branch point, because that will give you 0 here, and z equal to infinity is not a branch point. How you can determine? This can be written in this form. So that's how you get this z equal to 1 and minus 1 and 1 are branch point, and infinity is not a branch point because this sum of this a plus b is give you 1. So that's why z equal to infinity is not a branch point. So at z equal to infinity you can check the singularity. How? I told you this method. Means in place of f function, you will fz function, you will get some t function where you will replace z equal to 1 upon t. So you will get some different function gt. So in place of z we will write 1 upon t. That will give you 1 upon t square minus 1, and this will give you 1 upon t 1 minus t square 1 upon 2. Now you can expand this binomially. You will get this series. Now multiply 1 upon t inside. You will get this series. Now putting z equal to mean t equal to 0. So t equal to 0 is a simple pole. You can see this. Only this power you have. So this is your simple pole. So t equal to 0 means z equal to infinity. So whatever result you will get t equal to 0, that will give you result for z equal to infinity. So z equal to infinity is a simple pole. So that was means we checked for the z equal to infinity. Now what is the branch line for this? So if you are getting any two branch point, then you will just join these two branch point. That will give you your branch cut. So like we are getting here plus 1 and minus 1. So if you join these 2 points, so this line is called the branch line or branch cut. Means what is the meaning of this? Now if you draw any contour which don't cut this line, then that contour is single valued function, and then you can use that for the integrals. So let's say z minus 1 equal to p exponential I phi, and z plus 1 equal to r exponential I theta. So we determine for this one this equation, and for this one this equation. So how I write this? This is like z minus 1 for this. Okay, and you can write this distance is p. So you can write it in form of circle. So means any point lying there you can represent by this. So p is your radius, and exponential I phi represents the angle around this point. And same for z plus 1 you can write, means this distance is r. So r exponential I theta. Now why I did this? So if you multiply these two, that will give you this thing. Means z plus 1, in place of z plus 1 you can write this, and you can substitute for z minus 1 also. So you can substitute them here and you can get your fz. So fz will be this to the power half multiply this to the power half. So this will give you rho half r half e exponential I theta plus phi divided by 2. So now you have fz. Now why we did this? Now we see that if this is multi-valued function or not. This one means we get the branch line or the branch cut. Now we will make a contour which is not cutting this. Then we will find the value of this function and we will see that if we are getting different values or not. If we are not getting different values means it is now a single valued function. So let's see. We draw a contour. Contour is something like this. This is your branch line. So we made a line. This line is very closer to this line, very closer, but it is not cutting this. And this line is also very closer to this, but it is not cutting this. So we are just making something like this, very close line towards this, and it is like this. So this is your contour. Now this is not breaching or cutting this branch line. So this should be your contour, which is single value. So let's see. First we will take all the points. This is A, B, C, D, E, F. So for A point, what will be this phi angle? So this phi angle will be 0 and this theta angle will also be 0. Okay, from both these points. So point theta and phi are 0. So this theta plus phi by 2 you will get here 0. Okay, now let's go to the B point. Now here this B point is very closer to this line. So for this angle will be pi pi, and this angle will be 0. So this theta is 0 and phi is pi. Now again for the C point, this is very closer to this line. So this angle will be, for this it will be pi, and for this one it will be 0. So again it is 0 pi, and when you substitute here it will give you 0 plus pi, that will give you pi by 2. So you are getting pi by 2, pi by 2. Now for D, see this is very closer to this line, or this is on this line. So what is this angle? This angle is phi is pi, and this is also pi. This is pi pi. So pi plus pi, 2 pi divided by 2 will give you I pi here. Now for this E point, this is very closer to this, but this is downside of this line, means this is not cutting this line. So we will take it here. Now what will be the angle? So this angle is again pi. Theta means phi is pi, but this one angle, this theta is, it is complete circle, so it will give you 2 pi. So 2 pi plus pi, 3 pi by 2. When you substitute here, you will get this 3 pi by 2 as your theta plus phi by 2. Now for the F, it will be same, means pi for this, phi is pi, and this is 2 pi. Now for this again you will, when you reach this A point, so this will be 2 pi and 2 pi. So you will get this. Now see, when you start from A point and you are coming back to A point, you are getting the same value, because this is 0 and 2 pi. So 2 pi circle will give you again the same value, means you are not getting two different values at the A point now. But first, when we discussed, when you take this singular point inside, then we were getting two different values. And here also, if you anyhow cut this line, then you will get two different values or three different values. But now you are not cutting this line, and this is your branch line, then this is giving you the same value. So this is now single valued function, and you can solve this now. So that's how you can prove this. Let's see one example of branch point singularity. So we need to solve this integral, and this includes the log x function, that is your multi-valued function. So now first we need to find the branch line to make the single value. So how we can do that? So remember, for the 1 upon 1 plus x cube, you remember how we draw the contour. So for this there are three poles, that is z1, z2, z3. So see the previous example, I already drawn this, means this contour we drawn, and this angle was 2 pi by 3, and there was reason behind it, I already told it in that lecture. So now you will have contour for this, but now this log x is included, and this says that x equal to 0 is a branch point singularity. Now if this is your branch point singularity, then this means this is a multivariate function. Now to make it single value, you need to remove the branch line or branch cut from it. So how you do for the single point? So for 2 points you will join them, and if there is only 1 point singularity or branch point singularity, then you will add that point to the infinity, means that line which is joining that point to the infinity is called the branch line or branch cut. So this is your branch point, so you will join this point with the infinity. So this will be your now branch line or branch cut. Now this contour should not cut this or breach this line, then your function will be single valued. So to remove this point or this line, we just drawn a very small distance, delta tends to 0 here, and we drawn this contour like this. and we take this contour like this. Now we get this single value. Now this is single value, so we can solve this. So now what is the integral of this? So integral fz dz will give you, first you will take from 0 to infinity, then you will take this contour CR, then you will take this one from infinity to 0, then this one. This is nothing but a very small delta radius, so you can take this. So let's see, this is sum of these four integrals. The integral of this is sum of these four. First is 0 to infinity log x by 1 plus x cube dx. The second is the CR, and third is this infinity to 0, that is B. We call this A, this is B, this is CR, and this is C delta. This one is C delta. So this is log z by 1 plus z cube dz equal to, now this whole will be equal to, you know what is this? Just simple integral of this will be 2 pi iota multiplied by residue of this function, that is equal to this. Now see, this is a function like z fz, and z tends to infinity will give you 0. So from that you can make this contour equal to 0. So this will be 0. Now for the C delta, let's solve. Let's say z equal to delta exponential I theta for this contour, and delta tends to 0. So from here dz will be I delta exponential I theta d theta. So we'll substitute it here. In place of this, log z will give you this, and dz in place of dz we will get this. Now this delta tends to 0, so this will give you whole integral will be 0 after putting 0 here. So that's how this integral also be 0, means this one is 0, this one is 0. Now only two are remaining, this and this. For this one, we know this is nothing but z equal to r exponential I 2 pi by 3, because this angle is 2 pi by 3. And now you substitute z equal to this. So this B line, we'll solve for this line first. So this will be infinity to 0. Now z will be this, so log r plus I 2 pi by 3. Now see, this is a single value, so we'll get only this value for this, no any other values. So exponential I 2 pi by 3 from here, because z equal to this, so dz will be exponential I 2 pi by 3 dr. So that's how you will get this value. Now divide this from this and divide it in two parts. So we'll get, first we will change the limit, 0 to infinity will give you minus sign outside, and you will do like log r divided by 1 plus r cube, and minus I 2 pi by 3 divided by 1 plus r cube. So I just divided it in two parts. Now see, this is nothing but this is 0 to infinity 1 upon 1 plus r cube. This is your real part, so this is equal to your integral, that is I. This is equal to I. So in place of this you will write I. Well, this is not I, this one is I, because in the function we have log x also. So for the real value, this log, if you take this is constant, you will take this outside. Then this one, log r divided by 1 plus r cube, 0 to infinity dr is same like this. So we'll write in place of this I, and this will be this minus exponential I 2 pi by 3. Now minus this term, and this we already solved this one. This result was this 2 pi by 3 root 3. So in place of this we will write this. Now this is the value of this, and now plus we have what, this one. So this is already I, so I minus this one, so we will take I common, that will give you 1 minus exponential I 2 pi by 3 minus this term. So this whole integral is equal to this. Now what is the integral of this? Just we will solve this for the, means simply we can solve 2 pi iota multiplied by residue. So for the residue you will get three values for the singular points from 1 plus z cube is equal to 0. So those 3 points will be, so these will be your 3 points, z1, z2, z3. Now only the second or the first one, the exponential I pi by 3 is lying inside the contour. Here you can see this. So we need to find the residue only on this z1, but not on the z2, z3, because z2, z3 are outside this contour. So let's see. To find the residue, we know what is the formula, limit z tends to z1, z minus z1, and this is your fz, log z by z 1 plus z cube. Now z is this, means you need to find a similar residue only at this point. So what is the residue? So see, if z equal to z1, then this will be a 0 by 0 form. So what you will do, you will use the L'Hospital rule. So first find the differentiation of the numerator, then the denominator. In the denominator you will get 3z square, numerator you will get log z, because this will be two parts because of product rule. In the second part you will get again z minus z1, so that will be 0. So you only this one is remaining. Now see, at z equal to exponential I pi by 3, you will get this value will be solved to be this. Now this is your residue. So what is the value of this integral? This is nothing but 2 pi iota multiply residue. So 2 pi iota multiply this term will be equal to this complete term. Then you will try to solve, means this is equal to this one. Now from here this will go to the positive side of this, then I will be this whole term divided by this 1 minus exponential I 2 pi by 3. So this will take time, but you can solve that expression, and that will give you answer as 2 pi square divided by 27. So this will be your answer. Now that's how you can solve a question which includes the branch point singularity, okay, by turning it into the single valued function first. So now let me give you some results, because sometimes you just need to save the time. So how you can do that? So if this kind of function you have x to the power p divided by 1 plus x square, where this p is lying 0 to 1, so that means it is a multi-valued function. So how to solve this? Simply, if fz equal to zp divided by 1 plus z square, and then you will first find the singular points. So singular points will be z equal to plus minus iota, and z equal to 0 is the branch point singularity, because here is p is fractional, so z equal to 0 is branch point singularity. So you will join this point to the infinity to get the branch line or branch cut first. So this is z equal to 0, so this will give you your branch line. So you can't cut this line, then make the contour like this. The contour will be something like this, very close to this line but not cutting this line. So this will be your contour, and this plus and minus iota is lying inside the contour. So you need to find the residue on both these points to solve the integral. Then you can solve this by taking the limits. I will give you just simple example. If you get this kind of expression, then you just need to apply this result. Integral will be pi by 2 cos p pi divided by 2. Whatever value you are getting p here, so p is between 0 and 1, so then the integral will be pi by 2 cos p pi by 2. So you can remember this result, or you can use this contour to solve this, okay. So this will be more better option. Now there are some more integrals. So if you have something like this, x to the power a minus 1 divided by 1 plus x dx, where this a is greater than 0 less than 1, so this will be again the multivalued function. So answer will be pi by sine a pi. So simply use this result. Same if you have this 0 to infinity x a minus 1 divided by 1 minus x dx, then write this result pi cot a pi, where this a is lying between 0 and 1. Only then this will be your multivalued function, okay. So that's how you can solve the branch point singularity and multi-valued function and their integrals, okay. And how you made them single valued, so I already told you the ways, okay. So I hope this is understood to you. So here we end the complex analysis. In the next lecture we will start with vector analysis. So that's it for today. Thank you everyone.